before I talk to you about IMOS, I want to recognize that IMOS acknowledges the traditional owners of the land and sea on which we work and observe, and we recognize their unique connection to land and sea. We pay our respects to Aboriginal and Torres Strait Islander peoples past, present, and future, and we especially honor our traditional owners as Australia's first marine scientists and carers of country. So now, why do we need ocean observing? Like all of you here tonight, over 85% of the people in Australia live within 50 kilometers of the coast. We are an extremely coastal nation. These are the places where we live, we work, and we play. So to manage and sustainably manage our marine environment, we need to understand it. We need to observe it, see how it's changing, see what the trends are, so that we can make sure that we're good stewards for this environment. And that includes understanding climate change and the ocean processes that are going to change the shape of our coastlines, literally. As you can see, some of these images over here are not unfamiliar with people as we see our coastlines changing due to coastal wave processes. So I think there's a real opportunity for us to create benefit by working together for all Australians through observation and data sharing. And that's really one of the main premises for having a program like IMOS. As Diane said, we're a collaboration of 7 main partners. One of our major partners is the University of Western Australia. We also have 4 associate participant partners, and we're headquartered out of the University of Tasmania in Hobart. This program is funded through the National Collaborative Research Infrastructure Strategy, or NCRIS. That doesn't mean a lot to people, but NCRIS is actually the 2nd largest infrastructure program in Australia behind roads. So it is really critical to our research community and our ability to work in a range of fields, not just marine science. So as one of these capabilities inside NCRIS, we really have a singular goal, and that is to deliver benefits to Australia by undertaking sustained and scientifically robust observations of our marine estate. And this map here just shows you an indication of the breadth and reach of the infrastructure that we operate in this program. So the principles of the program, before I talk to you about what's actually involved, is really about contributing to community and management and policy needs of Australia. And we do that by delivering observations, supporting research, and partnering with industry and stakeholders to meet their needs, with the aim really of creating societal benefit. We've shaped our program around 5 areas of societal benefit where we think our data and our observations can play a role. And you can see those here on the right-hand side of the screen. So marine sovereignty, safety and security, energy and food security, biodiversity conservation, and supporting and managing coastal populations. We also then sort of aggregate our data up into some research themes as well. And those are really focused around climate research and understanding climate change, ocean management and knowledge generation, and then operational services, so helping industries that operate in the marine environment be effective and efficient. So what is it that IMOS does? Well, we operate over 60 different sub-facilities of research infrastructure around the country. This ranges from deep water moorings out in the Southern Ocean to ocean profiling floats that are collecting information through the water column. We have underwater vehicles like gliders and AUVs. We've got sensorized moorings along the shelf. We use ships of opportunity, so industry vessels and research vessels to collect data for us. We even do animal tracking, so we put transmitters in fish to see where they're going and where they're spending time. And we've actually even got the seals involved. We've got transmitters and receivers that we put on the seals so they can collect oceanographic data so we know what conditions they're swimming around in. So we've got a range of different data types that are coming in from around the country, and those are all distributed into our Australian Ocean Data Network, which is our major data repository. And as Diane said, the data comes into that system and it's made openly and freely available for anyone in research, industry, business, management to use and access to understand questions that they may have. And so our data are used really widely for a whole range of applications. Some of these won't be particularly surprising. Our data are used very heavily in oceanographic modeling, but possibly more surprising is that our data are actually really integral in weather forecasting and climate modeling. most people don't realize how critical the ocean is actually in driving our climate. The ocean absorbs a lot of heat. We have phenomena like El Niños and La Niñas that change our weather, and a lot of that is driven by ocean processes. So the data that we collect is really factors into the accuracy of your weather forecasts and whether you need an umbrella or not. We also use our data to help understand some of the extreme events that are happening in our system. So for example, marine heat waves. Now, more close to home for you, what is it that we're doing in WA? First, I want to acknowledge that there is a really strong marine science community in WA, and we consider that a huge asset to our program. We work with scientists all over the country, but this community is really well engaged and really valuable to us. We also have strong relationships with a range of industry, philanthropy, and WA government departments. So for example, the Department of Jobs, Tourism, Science, and Innovation actually co-invests in IMOS in WA. So your state government is investing in this program to help us do more. We also support infrastructure that's led by operators based here in WA, but then we use our operators that are based on the East Coast as well to bring their expertise here and collect observations to help better understand your region. So this is the very familiar to you coast of WA, and just a very busy picture of some of the things that we have happening along this coast. So we've got, as I said, ships of opportunity. These sort of blue lines, which are a little bit hard to see, show some of the tracks where we've got ships operating, collecting data. We have shelf moorings along the shelf to understand what's happening with the Lewin Current. We've deployed vehicles. These orange squiggly lines are ocean glider tracks that are designed to help understand the conditions in the water column in particular areas. And then we also have things like our new technology proving program, where we've been working with the group at UWA, and particularly here, around looking at the effectiveness of some Waveboys, which I'll talk to you about more in a minute. The other thing to mention in this program is we also collect satellite remote sensing data and process that. And then we don't create very many products for people to use, but one that we do have is a thing called IMOS Ocean Current. And using that program, we actually integrate data from a range of our facilities. So these are maps that are using satellite remote sensing data joined up with the profiling float data and the shelf mooring data to help us get an integrated picture of what the conditions are, whether the conditions are average or whether they're below or above average, and what they're changing and how they're changing through time. So now what we've been doing here more locally, we've been working in partnership with the University of Western Australia to trial through our new technology proving program some of the so far spotter Waveboys. We've been trialing these buoys because they're smaller, which means we can deploy them and recover them more easily. We can use them closer to shore, and they're more cost effective than the large buoys that we normally use offshore. But the question was, do they work as well, given that they're smaller and a slightly different system? So Ryan and his team at the university have been deploying floats around the country, and they've had one here in Albany. They deployed 2 drifting buoys in Bremer Canyon, and then the Minderoo Foundation co-invested with us to deploy one up off Ningaloo. So this has actually been extremely successful. In 2020, one of these Waveboys actually recorded a 9-meter wave off the coast of Perth when a superstorm was coming through the area. So I think we can comfortably say that they can handle the conditions and that they work. So this is really good news, and now we're looking at how we can apply this technology further in our program. Another thing we're doing in this program is trying to aggregate and coordinate in a national way. And sticking with the wave theme for this group, we're currently developing a national wave data archive. And that's including data from around the country and aggregating it all together into one single place so people can access it easily to understand wave conditions. From a Western Australian perspective, that includes data from 28 Waveboys that are managed by the State Department of Transport, as well as the IMOS UWA spotter buoys that are in the water. And really, this is designed to help us understand coastal conditions, so what's happening with erosion and where those changes might be happening along our coast based on wave activity. Another example of how we've been working sort of in a coordinated way in Western Australia was the marine heat wave that we had earlier this year. Not as severe as some of the heat waves that have happened in the past, But we were in a position this year where we could bring a lot of our technology to bear to help understand this. So we used some of our normal glider deployments were redeployed to understand this event. We have our shelf moorings. These Waveboys that the UWA team are trialing have temperature sensors on them, so we use the data from those. And then we also did some additional glider deployments based on the funding that the state government provided for us. And this really helped us understand the scale and scope and potential impact of the marine heat wave that occurred. So now, before I leave you, I just wanted to sort of come back to my point about why we need ocean observing. We had a return on investment analysis done for IMOS earlier this year, and the firm that did that work came out with a few conclusions that I thought were really valuable for us. And that is that we can't always put a dollar value on the things that we contribute, but the benefits of IMOS really have a long tail, and they stretch out to a range of things, including more accurate weather forecasting, as I explained earlier. Our data, the data that we have on fish and fisheries are helping the government improve their policy responses around how they manage some of these species. Our ocean temperature data is contributing to forecasts and trajectories around cyclones. So when will they come ashore? How intense will they be? Where will they come ashore? We work with oil and gas industry to help with their operations. So we have a coastal radar system that's off the Northwest Shelf. It's co-funded by Woodside Energy because they wanted data for that region, and then it makes it freely available for everyone. So we've got these linkages that help them with their business, but also help us and the broader community learn more. And finally, we work with defense, particularly the Navy, in providing information in locations that they need for their maneuvers and their operations, and contributing to them understanding their operating environment. So we do play a role, possibly in some ways that aren't readily evident from the outside. And lastly, I'll just say, if you would like to learn more about our program, please feel free to visit our website. Check out the Ocean Current page if you want to see any of those integrated maps on conditions. As I've said, all of our data is freely available through the AODN portal, and you're always very welcome to contact us at the office if you have questions or other interests. And I will say thank you very much to all of our funders, particularly NCRIS and the Government of Western Australia, and thank you.